The electrical inspector's arguments center on voltage drop. He claims that low voltage readings indicate potential fire hazards due to wire heating. He asserts that using a 20 amp load on a 15 amp receptacle is acceptable because the breaker will protect against overcurrent. Unbiased opinions. Firstly, voltage drop. Voltage drop is not explicitly defined or enforced in the National Electrical Code for dwelling units. Voltage drop depends on the current drawn and the length of the circuit. A low voltage reading may simply indicate a long circuit or a temporary high load. Wire heating is typically caused by high current, not voltage drop. The breaker will trip at 15 amps, regardless of voltage. Secondly, a 20 amp load on a 15 amp receptacle. Section 210.21b3 of the National Electrical Code clearly states that receptacles rated for 15 amps shall not allow continuous loads exceeding 15 amps. Overloading a receptacle can damage the wiring, receptacle, and connected devices, increasing the risk of fire. While the breaker will trip at 20 amps, it may not do so immediately, allowing excessive current to flow through the wires. Additional considerations. The inspector's test method is not standardized or validated by any electrical code or safety organization. The inspector is using a subjective interpretation of voltage drop and fire hazards, which is not supported by scientific evidence. The inspector's approach is unnecessarily stringent and creates an unreasonable burden on homeowners and electricians. The inspector's voltage drop and 20 amp load test is not supported by electrical codes or best practices. It is an arbitrary and potentially dangerous method that should not be enforced. Homeowners and electricians should respectfully question the inspector's reasoning and request evidence to support his claims. Understanding voltage drop is crucial in electrical systems. Voltage drop refers to the decrease in voltage along a conductor, such as a wire, from the source to the load. This drop is due to the resistance of the conductor. In simpler terms, as electricity flows through a wire, some of the electrical energy is lost due to the wire's resistance, causing a reduction in voltage at the end of the wire. The amount of voltage drop depends on several factors, including the length of the wire, the current flowing through it, and the wire's material and thickness. Longer wires, higher currents, and thinner wires all lead to greater voltage drop. Voltage drop can affect the performance of electrical equipment. If the voltage at the load is too low, the equipment may not operate correctly or may be damaged. For example, lights may dim, motors may run slower, and electronic devices may malfunction. To minimize voltage drop, it's important to use the correct wire size for the circuit and to keep wire lengths as short as possible. The National Electrical Code, often referred to as the NEC, provides guidelines for wire sizing to ensure that voltage drop is within acceptable limits. While the NEC does not explicitly mandate a specific voltage drop limit for dwelling units, it does recommend that voltage drop should not exceed 3% for branch circuits and 5% for feeders. Branch circuits are the circuits that supply power to outlets, lights, and appliances, while feeders are the circuits that supply power to branch circuits. The NEC provides formulas and tables to calculate voltage drop based on wire size, current, and length. These calculations help electricians choose the appropriate wire size to keep voltage drop within the recommended limits. It's important to note that voltage drop is different from overcurrent. Overcurrent occurs when the current flowing through a wire exceeds its rated capacity. This can happen due to a short circuit, an overload, or a ground fault. Overcurrent can cause the wire to overheat, which can lead to a fire. To protect against overcurrent, circuits are equipped with circuit breakers or fuses. These devices are designed to trip or blow when the current exceeds a certain level, interrupting the flow of electricity and preventing the wire from overheating. The size of the circuit breaker or fuse is chosen based on the wire's ampacity, which is the maximum current it can safely carry. The NEC provides tables that list the ampacity of different wire sizes. The inspector's argument that low voltage readings indicate potential fire hazards due to wire heating is not entirely accurate. While low voltage can affect the performance of electrical equipment, it's not the primary cause of wire heating. Wire heating is typically caused by overcurrent, not voltage drop. If the current flowing through a wire exceeds its ampacity, the wire will overheat, regardless of the voltage. The circuit breaker or fuse is designed to protect against overcurrent, not voltage drop. If the current exceeds the breaker's rating, the breaker will trip, interrupting the flow of electricity and preventing the wire from overheating. The inspector's test method of using a 20 amp load on a 15 amp receptacle is a violation of the NEC. Section 210.21b3 of the NEC states that receptacles rated for 15 amps shall not allow continuous loads exceeding 15 amps. This means that you cannot plug a device that draws more than 15 amps into a 15 amp receptacle. Overloading a receptacle can damage the wiring, the receptacle itself, and any connected devices. It can also increase the risk of fire. The fact that the breaker will trip at 20 amps does not make it safe to overload a 15 amp receptacle. While the breaker will eventually trip, it may not do so immediately. During that time, excessive current will be flowing through the wires, which can cause them to overheat. Additionally, the breaker may not trip at exactly 20 amps. Breakers have a tolerance range, which means that they may trip at slightly higher or lower currents. The inspector's test method is not standardized or validated by any electrical code or safety organization. There is no requirement in the NEC or any other recognized standard to perform voltage drop tests at receptacles using a 20 amp load. The inspector's approach is unnecessarily stringent and creates an unreasonable burden on homeowners and electricians. It is important for electrical inspectors to follow established codes and standards when performing inspections. Deviating from these codes and standards can lead to confusion, disputes, and potentially unsafe conditions. Homeowners and electricians have the right to question an inspector's methods if they believe that they are not in accordance with the NEC or other applicable standards. If you encounter an electrical inspector who is using questionable methods, you should first try to discuss your concerns with the inspector. Explain why you believe that the inspector's methods are not in accordance with the NEC or other applicable standards. If you are unable to resolve the issue with the inspector, you can contact the inspector's supervisor or the local electrical authority. They may be able to provide guidance or intervene in the situation. It's important to document any issues or concerns that you have with an electrical inspection. Keep records of any conversations that you have with the inspector, as well as any evidence that supports your claim. This documentation can be helpful if you need to escalate the issue to a higher authority. Remember, electrical safety is paramount. If you have any concerns about the safety of your electrical system, it's always best to consult with a qualified electrician. They can inspect your system and make any necessary repairs or upgrades to ensure that it is safe and code compliant. Understanding these aspects of electrical inspections and code compliance is essential for homeowners and electricians alike. By staying informed and following best practices, you can help ensure the safety and reliability of your electrical systems. Furthermore, it is critical to differentiate between voltage drop and overcurrent protection. Voltage drop, as previously mentioned, is the reduction in voltage along a conductor due to its impedance. Overcurrent, on the other hand, is a condition where the current exceeds the rated ampacity of a conductor or device. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when an overcurrent condition occurs, preventing damage to equipment and reducing the risk of fire. The NEC provides detailed requirements for overcurrent protection, including the selection and installation of circuit breakers and fuses. These requirements are based on the ampacity of the conductors and the type of equipment being protected. It's important to note that voltage drop and overcurrent protection are two separate but related concepts. While voltage drop does not directly cause overcurrent, excessive voltage drop can affect the performance of equipment and may indirectly contribute to overcurrent conditions. For example, if a motor is operating at a significantly reduced voltage due to voltage drop, it may draw more current in an attempt to maintain its output power. This increased current can lead to an overcurrent condition if it exceeds the motor's rated current or the ampacity of the circuit conductors. In the scenario described, the inspector's focus on voltage drop as an indicator of potential fire hazards is misplaced. While excessive voltage drop can have negative effects on equipment performance, it is not the primary cause of wire heating and fires. The primary cause of wire heating and fires is overcurrent, which is effectively addressed by overcurrent protection devices. The inspector's use of a 20 amp load on a 15 amp receptacle is a clear violation of the NEC and poses a safety hazard. This practice overloads the receptacle and the connected wiring, potentially causing overheating, damage to equipment, and an increased risk of fire. The fact that the circuit breaker may eventually trip does not justify this practice, as the receptacle and wiring are still subjected to excessive current during the time it takes for the breaker to trip. It is essential for electrical inspectors to adhere to the requirements of the NEC and to use standardized and validated testing methods. The inspector's subjective interpretation of voltage drop and fire hazards, without supporting evidence or code references, is not acceptable. Homeowners and electricians have the right to question such practices and to request clarification and justification from the inspector. In conclusion, the inspector's voltage drop test using a 20 amp load on a 15 amp receptacle is not supported by electrical codes or best practices. It is an arbitrary and potentially dangerous method that should not be enforced. Homeowners and electricians should respectfully question the inspector's reasoning and request evidence to support his claims. It's important to remember that electrical safety is a shared responsibility, and everyone involved should work together to ensure compliance with the NEC and other applicable standards. Furthermore, understanding the principles of circuit testing can help clarify the issues at hand. When testing a circuit, it's crucial to use the appropriate equipment and methods to obtain accurate and reliable results. In the case of voltage drop testing, it's important to use a voltmeter that is properly calibrated and has sufficient accuracy for the application. The voltmeter should be connected as close as possible to the load being tested to minimize the effects of lead resistance. When applying a load to the circuit, it's important to ensure that the load is within the rated capacity of the circuit components, including the receptacle, wiring, and overcurrent protection device. Overloading the circuit can damage the components and create a safety hazard. In the scenario described, the inspector's use of a 20 amp load on a 15 amp receptacle is a clear example of overloading the circuit. This practice violates the NEC and poses a safety hazard. It's also important to consider the duration of the load test. Applying a load for an extended period can cause the circuit components to heat up, which can affect the voltage drop readings. Therefore, it's important to perform the test quickly and efficiently to minimize the effects of heating. When interpreting the voltage drop readings, it's important to compare them to the recommended limits provided by the NEC or other applicable standards. If the voltage drop exceeds the recommended limits, it may be necessary to upgrade the wiring or reduce the load in the circuit. It's also important to consider the type of load being tested. Different types of loads can have different effects on voltage drop. For example, inductive loads, such as motors and transformers, can cause a greater voltage drop than resistive loads, such as lights and heaters. In the scenario described, the inspector's focus on voltage drop as an indicator of potential fire hazards is misplaced. While excessive voltage drop can have negative effects on equipment performance, it is not the primary cause of wire heating and fires. The primary cause of wire heating and fires is overcurrent, which is effectively addressed by overcurrent protection devices. The inspector's subjective interpretation of voltage drop and fire hazards, without supporting evidence or code references, is not acceptable. Homeowners and electricians have the right to question such practices and to request clarification and justification from the inspector. In addition to the technical aspects of voltage drop and overcurrent protection, it's also important to consider the legal and ethical implications of the inspector's actions. Electrical inspectors have a responsibility to enforce the NEC and other applicable standards in a fair and consistent manner. They should not use their position of authority to impose arbitrary or unreasonable requirements on homeowners and electricians. If an inspector is found to be acting in a negligent or unethical manner, they may be subject to disciplinary action, including suspension or revocation of their license. Homeowners and electricians who believe that an inspector has acted improperly have the right to file a complaint with the appropriate regulatory agency. The complaint should include detailed information about the inspector's actions, as well as any supporting evidence. The regulatory agency will investigate the complaint and take appropriate action if necessary. In conclusion, the inspector's voltage drop test using a 20 amp load on a 15 amp receptacle is not supported by electrical codes or best practices. It is an arbitrary and potentially dangerous method that should not be enforced. Homeowners and electricians should respectfully question the inspector's reasoning and request evidence to support his claims. It's important to remember that electrical safety is a shared responsibility, and everyone involved should work together to ensure compliance with the NEC and other applicable standards.